Hello everyone, welcome back to my channel. So today we are going to discuss another problem, but before going forward, if you not like the video, please like it, subscribe to my channel and hit the bell icon so that you get notified whenever I post a new video. So without any further ado, let's get started. So problem is contiguous array. In this problem we'll learn a very important concept, right? So stay tuned. So what we have to do in this problem is we'll be given a array of numbers. It's a binary array, so we'll have 0 and 1. Return the maximum length of contiguous subarray with an equal number of zeros and ones. So we have to find a subarray which will have equal number of zeros and ones. And the maximum subarray which is, we have to return its length. So if you see over here, this is the subarray of 2 length and it has equal number of 0 and 1. So 1, 1, 0 and 1. 2 is the output. And if you see in this array, we have this subarray which has 1 0 and 1 1, so its length is 2, and this could be also another subarray which has equal number of zeros and ones, right? So output is 2. Now let's see how we can approach this problem. Over here, see, we will be taking this test case. So over here we have to find, what we need to do is, see, we need to find a subarray. We need to find a subarray, and that subarray should have equal number of zeros and ones, right? Equal number of zeros and ones, right? And maximum length of such array we need to find, maximum length, and that maximum length we need to return. That will be our output. So over here, see, this is one subarray. This is one subarray which has equal number of zeros, equal number of ones, 2 zeros, 2 ones. This is one subarray. If you see this one, this has again 3 zeros and 3 ones. So this is also a subarray of equal number of zeros and ones. And this one, this is also a subarray. See, this one, it has also equal number of zeros and ones. So there are 4 ones and 4 zeros. So from all these 3 subarrays, also we have this smallest subarray. This also has equal number of zeros and ones. So among all these subarrays which have equal number of zeros and ones, the maximum length one is this one, the yellow one. And its length is what? 1, 2, 3, 4, 5, 6, 7, 8. So the output for this will be 8. Output will be 8. Right? So this is the problem. Now see guys, how we'll approach. So whenever there is subarray given, we have to find a subarray. So whenever subarray is given, nested loop approach is the brute force approach. That we'll have 2 nested loops. We will find all the subarrays. We'll find the subarrays which have equal number of zeros and ones, and we'll be calculating, like we'll be finding the max length accordingly. That is how, see, we have this test case. So what we will do is, we will have 2 loops, like I loop here and j loop here. So we'll have 2 nested loops for I in this length till n. From, like, it will start from 0 and it will go till length, and j will be starting from I and it will go till n, right? So what will happen is, every time we'll be considering all subarrays. We will have 2 variables, zeros and ones. We will be storing the count of zeros and ones. How many zeros are there, how many ones are there. So first of all, this subarray will be considered. Then this subarray will be considered. This subarray will be considered. Whenever, see, when this subarray, this 4th subarray is being considered, zeros will be 2, ones will be 2. So zeros and ones are equal. So this could be our 1 subarray. So we will have a length variable in which we will be calculating the length. Of how, like, what is the maximum length till now of the subarray which has equal number of zeros and ones. So when zeros and ones, like if your zeros is equal to ones, when zeros and ones become equal, so we will see what is the length. Length is what? 4. So we will update 4. Right? Like this, you will calculate for this, all these subarrays you will consider. Then your I will increment, I will come here. So now you will be calculating for these. So like this will happen. So all the subarrays you will be considering and all the subarrays you will find, like you will be keeping zeros and ones, and you will check when the zeros and ones become equal. So like over here for this subarray, zeros and ones will become equal. Zeros will be what? Zeros will be 3 and ones also will be 3. So this could be your one subarray. So what is its size? Its size is 6. So you will update this like this, right? And similarly, if you go forward again, if you go ahead for this, and when it will come to here zeros will become 4 and ones also will become 4. So this is of length what? 8. So 8 will get updated. Right, so this is brute force approach. We are having two nested loops and we will be calculating the maximum length accordingly. So O of n square will be time complexity for this, n square, because we have two nested loops. And space complexity will be what? Space complexity will be nothing, like we are not using any extra data structure. So we are just taking this length variable and these variables, zeros, ones, and right. So it will be constant. Space complexity will be constant. Right. Now we need to see, we need to optimize it, right? On square will not get accepted. If you see over here, constraint is what? The max length is 10 raised to power 5. So 10 raised to power 5 is, if n is 10 raised to power 5, then n square will be what? 10 raised to power 5 into 10 raised to power 5? 10 raised to power 10. So this is greater than 10 raised to power 9. So this will give you TLE. This n square approach will give you TLE, right? That this will not get accepted. So we need to think of a optimized approach, right? So see how we will think of that. What we are doing every time, what we are doing is we are calculating for all subarrays, na? We are going and we are calculating for all subarrays. Let's do one thing. Just a second. I'll write this test case again. See, this is in this problem now you will learn a new concept, right? You will learn a new concept. So the extra work we are doing over here na, is that every time for each subarray we are calculating the sum, right? For every subarray we are doing that, right? How we can avoid that? See, first of all, before going to this, let's take a random case. Like we have some numbers. Let's say we have this array A, B, C. We have D, E, F. These are some numbers like A, B, C, D, E, F. These are some numbers, right? And let's say sum of ABC is 5. That is A. If you do A plus B plus C, these are some variables. If you do A plus B plus C, that comes out to be 5, right? And if you take sum of this whole thing, that is, if you take sum of A plus B plus C plus D plus E plus F, that also comes out to be 5. So what was that? Like A plus B plus C is 5. That is, this thing is 5. So what do you think this thing will be? This thing will be 0, right? Because if this A plus B is 5 and this whole thing is 5, then this will be 0 only, right? So this problem which we are doing over here, this problem, contiguous array. This problem is a extension of count. This is count of subarrays having sum 0. So this problem is an extension of that. Same concept is used in this problem. Count of subarrays having sum 0. Right. So if you will solve this problem, you will be able to solve this problem also, right? So over see, like if we have to find a subarray which has 0 sum. So what will that be? This one, because this subarray has sum 0. This array has sum 0. So what we can do is, like, if this is 5 and this whole thing is again 5, means whatever is this part, that will be 0. So we found our subarray which has sum 0, right? This is one concept. So just this was for understanding. So just keep this in mind. Now let's see how we will solve this problem. So what we will do now, we will use same concept. The concept is what we will do first of all. Now we will replace all these zeros. We will replace all the zeros with -1, right? 0 is there, so we'll replace it with -1. 1 will be as such, 0 will get replaced by -1. Then this 1 will be as such, this 0 will be -1, this 0 will be -1, this 1 will be as such, this 0 will be -1, and this 1 will be 1. You will understand why we are replacing 0 with -1. We are doing because, see, if a subarray has equal number of zeros and ones, so if you change these zeros to -1, then the sum of this subarray, which has equal number of zeros and ones, will come out to be 0. -1 plus 1 -1. So that's why in order to get sum 0, we are converting 0 to -1. We are changing 0 to -1, so that we can know that if sum of a subarray is coming 0, then it means that it has equal number of zeros and ones, right? It has equal number of zeros and ones. Why? Because 0 is changing to -1. So if zeros are 2, so what will be -1 -1 -2? And if ones are also same count, so 1 plus 1 will be 2. So 2 minus 2 will come out to be 0. Right? For example, if here there are not equal of number of zeros and ones, here is 0 1 0, and here also there is 1. So 0 0 will be minus 1 minus 2, but ones will be 1 plus 2 plus 3. So 1 will be this. So here sum will not come out to be 0. So if the sum is 0, it means it has equal number of zeros and ones. So this will be this approach we will use. This will be the deciding factor, that whether we'll be finding subarrays only. If a subarray is there and its sum is 0, then it means it has equal number of zeros and ones, and that could be that could be our answer. That could be our answer, right? So let's see how we will do this. I hope you are getting this point. So see, what we will do now, we will take a hash map. You will understand why we are taking a hash map. We will take a map, unordered map or a hash map, right? And what we will do is we will take few variables. First will be you can say first will be max length. This will be storing the maximum length of the subarray, right? Initially give it 0. Then we will be taking we will have a variable, this one, like we'll have sum. We'll be having a sum variable, right? And we will iterate on this array. So right now, just look. Now this is your array, right? This is your array. This is your array, right? This is your array. You have to look into this. Now we have changed zeros to -1, right? This is your array. So I'll do indexing quickly. So 0, 1, 2, 3, 4, 5, 6, 7 and 8. So what we will do is, we will start iterating. So here I will start from 0. So I will start from 0. So this has -1. So our sum will become -1, right? Now we'll go ahead. I is changed to 1. Now this is 1. So sum will become what? -1 plus 1. Sum becomes 0. So now sum becomes 0. Sum becomes 0 means we got a subarray which has equal number of zeros and ones. That is this. See, this one. 0 and 1 was there, na? So this is equal number of zeros and ones subarray. So sum becomes 0. That means we got a subarray with equal number of zeros and ones. Right? See, also earlier before this step, what was the sum? Sum was -1, na? Sum was -1 when I was here. So sum was -1. So what we will do, na? We will store this sum and its index in a hash map. So sum we got what? -1, and index was what? 0. So you'll understand why we are storing it, but just for now we are storing sum and the index. So then after that we go to I was here, so I came here, and then sum becomes 0. So sum becomes 0 means we got a subarray. We got a subarray with equal number of zeros and ones. So we will update our maximum length. Maximum length will be what? I. Maximum length will be I minus I plus 1. That is, I is here what? 1. But length is what? 2 na? So I plus 1 will be the length. So I is 1, 1 plus 1, 2. So max length is right now 2. Right now 2. And here we got 0 sum. 0 we will store in the hash map. So hash map 0 sum was occurring at what index? Occurring at 1 index. Like as in we are storing this sum, that this sum is coming is still what index? It's still 1 index, right? 0 sum is still 1 index. Now I will go ahead. I will go here. So I will be at 2. Now what is this? Minus 1. So 0 minus 1, it becomes minus 1. It becomes minus 1. Now see, now it's a very important point. Over here, we got minus 1. Till now, see, what are elements? Minus 1, 1 and minus 1. So starting from this till this, sum we got is minus 1, right? We got minus 1. And earlier also, if you remember, we got minus 1 at what? At what? We got minus 1 at 0 index. That is for this thing. Just for this thing, this subarray, one element is also a subarray, na? So for this subarray, we also got a sum minus 1. We got some minus 1. So guys, see, same concept which we discussed earlier. If this is A, B and C, if A is equal to minus 1, and if A plus B plus C is equal to minus 1, is equal to A plus B plus C is equal to minus 1, right? Then A is minus 1. So what will this be? This will be 0, na? So B plus C will be 0. That is B plus C. See, 1 and minus 1. This is 0. And we know that if sum is coming out to be 0, it means it has equal number of zeros and ones. Here, see, 1 and 0. Equal number of zeros and ones. So that's why we are storing this sum. At every index, we are storing in the hash map so that we get to know where was the same sum occurring last time. And the elements between these elements will be a subarray having sum 0, because this sum is occurring again here. This sum is here again. So this between elements will have sum 0. Right? So now what we will do, we will see that okay, this sum is minus 1, and is this sum present in the hash map? Yes, it's present. Means we earlier got this sum. So the elements which are between have sum 0, will have sum 0. And if they have sum 0, means they have equal number of zeros and ones. So that could be our subarray. So we will find the length of these. We'll find the length. And how we'll find the length? It will be what? It will be, this is I minus this index. This index, which is where the last sum minus 1 was occurred. So that we will get from what? Map of what? Minus 1 is what? Sum. So I is currently 2. 2 minus m of sum. Sum is what? Minus 1. So minus 1 is what? 0. 2 minus 0 is what? 2. So this is how we get the length. So right now max length is 2, so we will not update it. This is how you get the length. One way is getting length this way. This way we get length when we are starting a subarray from 0 and we get a sum 0. And this way, this is the way if the subarray is occurring between, like some between subarray is there, right? So this is how we calculate. So now let's go ahead and see. You will understand if you're not able to. When we'll further iterate, you will understand. So let's go forward. So over here, what will happen? I will go to 3 now. I will go to 3 and we will not update this minus 1. Minus 1 is 0 only because we need to have the maximum length. Na? So the first index we will keep. So here minus 1 plus 1 will become what? 0. 0. And 0 we are getting. So if we are getting some 0 means from here to here. See, from here to here we have a subarray with equal number of zeros and ones. So length will be what? I plus 1. I plus 1 is what? 3 plus 1, 4. So here we update and this will be 4. This will be 4. We will not update 0 here. 0's index will be 1 only. Because see, we have to have minimum index here so that we can have maximum length. If we have this minimum, this length will increase. Na? So we will not update this 0 with now 3. This will not change to 3 because otherwise this will be minus 3. Na? And if we do not update it, then it will be minus 1. So we have to have maximum length. So we will be keeping the earliest index only. That is 1. Right? Now let's go forward and I will come here. So I will come here. So this will be 0, minus 1, minus 1. Now just pay attention guys. See, again we get minus 1. And minus 1 was occurring earlier at what? 0 index. So see this array. We have minus 1, 1, minus 1, 1 and minus 1. So this whole sum is coming out to be minus 1. And earlier we got minus 1 at what? Here. So between all these all will be having some 0. Right? These all will be having some 0. So how we will calculate the length? I is what? 4. 4 minus m of sum is what? Minus 1. So minus 1 is what? 0. 4 minus 0 is 4. So 4 is already max length is 4. So we will not update it. We will not update it. So we will go ahead now. I know it's a bit of tricky, but it's very easy, right? Once you understand it, it's very easy. So I will come here. This will become minus 1, it becomes minus 2. So minus 2 is not in the map. Not in the map now, so we will add its entry. Minus 2 sum at what index? At index 5. Then we will go further. So this will be 1. So minus 2 plus 1, it will be minus 1. See guys, again we got minus 1. So see what the array is. Array is what? Array is minus 1, 1, minus 1, 1, minus 1, minus 1 and 1. And for this whole thing, we are getting some minus 1. And earlier minus 1 we got for what? 0. This thing. So this whole thing will have some 0. See, this is 0, this is 0 and this is 0. So how we will calculate the length? I is what? 6 minus m of sum is what? Minus 1. So m of minus 1 is what? 0. 6 minus 0, 6. So the length is of the subarray is 6. So we'll update this. So this 4 will now update to 6. Right? I hope you're getting very easy. And then let's iterate further. So I will go ahead. I will come here. I will come here. So this will be what? Minus 1. So minus 1, minus 1, minus 2. So now see, earlier we got minus 2. Minus 2 na? Earlier we got minus 2 and again we are getting minus 2. So earlier we got minus 2 at index 5. So how we will calculate the length? The subarray length? I is 7 minus m of minus 2. 7 minus m of minus 2 is what? 5. So 2. See this array. This array is a subarray which has 0 sum. Na? So this is equal number of zeros and ones. So 2 length 6 already is greater, so we will not update it. We'll go ahead. So I will now come here. Now see, very important, see 1. So minus 2 plus 1 will be minus 1. Now again we are getting minus 1. See guys, again we are getting minus 1. Right? So whole array sum is minus 1 and minus 1 what we get, where we got at 0 index, that is here. So these whole elements will have some 0. How we'll get it? I is 8 minus m of minus 1. 8 minus m of minus 1 is what? 0. So 8. So here we'll update 8. And we got max length. We have traversed the entire array and we got the max length. Right? I hope you understood the dry run and the approach, guys. Very simple. So see, whenever you have subarray, you have subarray and you need to find equal number of zeros and ones, subarray sum equal to 0. You will use this approach, the hash map approach, where you will be storing this sum. sum and its index, right? So let's see the code. See, very simple code. We have taken this map int comma int, because what we are storing sum and the index. So int comma int, and firstly what we did, we changed all the zeros to -1. So all the zeros are changed to -1. We have this loop. After that, what we are taking, we have this two variables na. We have two variables. One is the sum and one is the max length. So here I am taking sum as 0 and max length I have taken this res variable. And then I'm iterating, and every time I'm finding the sum. And if the sum is 0, means the length is I plus 1. That is from starting only, starting till some index, we get a subarray of equal zeros and ones. So that will be how you'll calculate its length, I current index plus 1. Because plus 1, why? Because its index is na, so one length you need to increase, one need to add. And otherwise, if the sum is in the hash map, this will check. If the sum is in hash map, sum is in map, then if you remember, -1 was in the map. So what we did this na, to find the length, I minus m of sum. So I minus sum, this will give you the length, and you will compare with the rest and update it. Otherwise, if it's not in the map, sum is not in the map, like -2 was not in the map, so you added it. So sum, add and the index of it, add it, and at last you will return the max length. So I hope you understood it. If you submit this, it gets accepted. And the time complexity for this is O of n. Why? Because we are doing this single traversal. See, and in unordered map, this find is O of 1 time, average case O of 1. And extra space we are taking, so extra space complexity will be O of n. Space complexity will be O of n, and time complexity is O of n. So right, I hope you understood, guys. Very easy problem, right? Very easy problem. And if you found the video helpful, please like it, subscribe to my channel, and I'll see you in the next video.